Okay, so the unit root, we're carrying on here. We were talking about the random walk previously, and I do not want you to confuse this with the unit root. The unit root says that beta 1 is equal to 1. I know that sounds like a random walk, but let's keep these separate again. Remember, we talked about this. I think that you need to keep these concepts separate, so when you're on the exam, you're not overthinking it, and you're not going to trick yourself, and now you're going to come up with the wrong answer. So let's think about these as independent items here. Questions, one off, that's it. So the unit root. So now, how are we going to identify the unit root? We're going to use that Dickey-Fuller test. Okay? Now, our learning outcome statement says they want us to describe the Dickey-Fuller test, so you're not going to do anything really in-depth, okay? I think that for this Dickey-Fuller, they must give you the critical values. You're not calculating anything. So for this Dickey-Fuller, you're going to be given, in my opinion, you're going to be given a Dickey-Fuller t-stat. You're going to be given a Dickey-Fuller critical value or rejection value. And now, just remember with our decisions here, our t-stat must be below the critical value in order to reject the null hypothesis. So let's fill in these blanks. If the t is below the critical value, reject the null hypothesis. So now we have to talk about what this null hypothesis is. So this is the Dickey-Fuller test for unit root. Okay? And we know if there's a unit root, then the series is not mean reverting. Well, okay, so what did Dickey-Fuller come along and said, okay, well, let's look at this beta 1, the slope. And let's replace this. Let's look at something called G. And we'll say G is equal to beta 1 minus 1. Okay, so this is what Dickey-Fuller came along. Now we run a hypothesis on this letter G. Do you even need to know that? No. You need to know this. The null hypothesis says that G is equal to 0. So what does that mean if G is equal to 0? If G is equal to 0, then that means by definition beta 1 must be equal to 1. And there's a unit root. Okay, so unit root. That's what it means. And the alternative, G is less than 1. G is less than 0. Okay, so what does that mean? Well, that means that our beta 1 is less than 1. So there's no unit root. Okay, that's it. Don't get caught up, you know, people ask about whether it's a one-tail, two-tail test. You don't even have to worry about that. Why? Because you're going to be given the t and the critical value. So all you have to do is be able to look at those numbers and identify if the t value is less than the critical value, you reject the null. What does rejecting the null mean? It means that there's no unit root. So there it is. This is how we crack the code on a unit root using the Dickey-Fuller test. And there you go. What else are you expecting to see on this exam? So we're just building up our marks to get over the passing score.